then you plug in sine of 0.
Well, you know that's already going to be
0.
Yeah.
So you put 0.
So you could just plug it. And then now you can also plug that point on the top.
Should it be here?
Yep. Now, what's sine of 90?
90's in the first quadrant as well, right?
Well, those are the ones that are really in a quadrant. They kind of make up. But those are always going to be like your 0 and 1s.
So that's 1.
Yep.
So 1. That would be on the sine is 0. Sine is y. So it'd be here. Now you do sine of.
I just find this one. Is this graphic or? No, it is a pattern. Then we got the.
Is it like this?
So if this is a function, right? Think about this function here. Does this represent the x or the y? The x, that's the input. What does this represent? The y. So if I input 0, what do I output?
0.
So put a point in it. What's the next one? What's the input for this? What's the input?
90.
90 degrees. What's the output? 1. Excellent. Keep going.
Não, mas não tem que colocar um 90 com um aqui em cima? Are you telling me something?
Clap once if you can hear. Clap twice. Clap once. Clap twice. Clap half. Oh, who do I get? I got someone. Oh, Pierre, come on, man. All right. I love the effort in here, and I love some of the work that I'm seeing, okay? At this point, I want 100% eyes on this board. I want to show you this animation, okay? I want 100% eyes on the board. I'm still waiting on about 4. Still waiting on about 2. Okay. This is the unit circle we talked about over the course of the last 2 days. We referenced how it's a periodic function. It goes on forever. I want to show you how it relates to what you just sketched underneath number 2. I want 100% eyes on the board. It's a really powerful animation. Okay? Notice, we're going to start at the initial side and notice the function as we go around the unit circle. I'm going to play that one more time. Notice the sine curve as we move the point around the unit circle. Okay. Now, does this sine function stop here? Yes or no? Call it out. No. What type of function? I just said it. So what type of function? It's a periodic or circular function. Okay. That curve is going to keep going forever and ever, right? It is a periodic function. Okay? Another thing I want to point out as I was walking around and monitoring all of your data, right? I see a lot of people drawing really sharp lines, and it comes to a point. I want everyone to look at this graph. Is this sharp here, right here? No, right? What shape does it kind of sort of look like a little bit?
Parabola.
It looks like a parabola. By the way, you guys can call this out. What type of function does a parabola model?
Quadratic.
Right? That's the kind of shape it is for a sinusoidal curve. I can't really say that word. Right? A sinusoidal curve. It follows that shape. And this never stops. It goes on forever. Okay? With your table partners, knowing what you know now, I want you to graph the cosine curve, and then I want you to think critically about question number 6. Okay? I'm going to give you 4 minutes. I want to see every single person working on questions 4, 5, and 6. Level 1, go! If you have any questions, throw your hands up. I'm more than happy to help out. I absolutely love your graph. Right, first you guys keep going up. Right, I think it's going to help me.
They are flipped. You can even see it in the following angles.
There it goes. Keeps on going on. So what's another like way to say like flip?
Interchangeable. Reflecting.
So they're just reflecting.
Oh, reflecting you said too, right? I said interchangeable, but I don't know if that's really correct.
I mean, yeah, it's actually good.
They're the same numbers, but they're just like this one. The one is on this side, and then on this.
Timeout. Called by Mr. Paulsen. This is his first team charge timeout. He has 1 remaining. A couple of things I noticed, and I love the effort in here, right? I see a lot of people drew sine curves and cosine curves that ended after 1 period, right? They went up to 360 degrees, right? That's correct, but I would really love for you right now to add to it, because these are periodic functions, right? I want you guys to see that this function goes on forever, okay? So let's label that, right? And I know it's labeled for us already, but I really love for us to label the graph as well, okay? I really love for us to label the curve as well. And I'm walking around and I love these cosine curves too, right? Again, the smoother and circular we make that, the more accurate those cosine graphs are actually going to look. Tomorrow, we're going to spend more time looking at sine and cosine curves and actually use the TI-84s to assist us. Okay? This is what I would like us to do right now. I want everybody to turn to page 2. And this time, we are going to go backwards, right? This time, I'm going to give you the coordinate, and you are going to tell me what is the angle, okay? Before we begin with that, I gave you space there to draw a unit circle, okay? I want us to think silently at a level 0. Do not call out, right? If I'm thinking about my unit circle, we said earlier today that the height, the y value, can be represented by a specific function, and the base, the x value, can be represented by a specific function. Silently at a level 0, I want us to think, which trig function represents the x value, which trig function represents the y value. Silent, level 0. When I say go with your table partners, I want you to have a conversation. Which trig function represents the x value? Which trig function represents the y value? Be ready, I'm going to the cards of fate. 30 seconds, level 1, go! Coming back full group in 3. Only my voice in 2. Ready to go in 1. Nice and loud, level 2 voice. I'm going with Greg. Greg, nice and loud, level 2.
Cosine represents x and sine represents y.
And what are you going to ask the class?
Agree or disagree?
Let's give Greg a 1 clap on the count of 3, 2, 1. If you would like to draw your unit circle, I see some people have started already, okay? Label the base, as cosine theta, and label the height as sine theta, okay? That might help you with this. Are you guys okay if notes like a halftime today? All right. With your table partners, I'm going to give you 3 minutes. I want to see if you can do B, C, and D. 3 minutes, level 1. Go. Yeah, you can go. Alpha's like theta, right? Sometimes if they use to remeasure, they'll use alpha instead of theta, but they're theta.
Oh, Paulsen.
Alpha, yeah.
Paulsen, that's the same as 13.
What is that?
That's the same as 13.
Yes. Oh, you need that stuff?
What is a justifier into 2 words by connecting 2?
So we're doing B, C, and D after we finish drawing our unit circle?
Oh no, just what ends, yeah.
You go, Trace. You did a great job. I love how you reference the unit circle. Bring it up. Actually, no, bring it up. Snap once if you can hear me. Snap twice. Snap once. Snap twice. You guys, I know some of us are confused. That's okay, right? This is some serious stuff we're doing right now, right? This is like hardcore pre-calc, okay? Charisse is going to explain how she thought through letter B. Charisse, nice and loud, level 2 voice. The floor is yours.
So B, I got A equals 60 degrees and theta equals 60 degrees because on the reference, if you look at 60 degrees, it has half, comma, radius 3 over 2.
Let's give Teresa one clap on the count of 3, 2, and 1. We just did a turn and talk a second ago, right? You guys can call out this time. What trig function did we say represented x? Call it out. What trig function did we say represented y? Call it out. So this time, we are actually working backwards from what we did underneath question number 1. There's a lot of different ways you could think about it, and that's okay, right? And again, we're going to get plenty of practice with this, okay? That being said, I want to see if we can now do C and D after Cerise gave us that great explanation. Again, you all have unit circles. Feel free to use those. I'm going to give you another 2 minutes at a level 1. Go!
You see it? You see it? Just one.
So, judging by this, we are going to be looking at 30 degrees.
It's not even the thingy we did the other, I mean, yesterday. It's there.
The measurement of this degree is 60 degrees. The length of the hypotenuse is 1. Right? So I know if I was thinking about the triangle, the opposite side is going to be sine. The base is going to be cosine. Right? Yeah. Put those in the calculator.
How would you know that? How would you find that? How would you find that here? So it's not there.
See, like, what is it? If you do 1 divided by rad 2,
1 divided by
radical 2.
1 divided by
Second, yeah, second. It's about second first. Second. 1 divided by second, 2. It just puts the parentheses in. It's the same thing as radical 2 is 2.
Step
And
twice.
then right here, radical 2
Snap
over
once again.
radical,
Snap
radical
twice.
2 over 2 or radical
Letter
2.
C, nice and loud, Chimera. What do you have for letter C?
I put 8 through 30 degrees
I love it. How'd you get 30 degrees, Pat?
because I saw a reference triangle and wanted a circle. Yeah, that's the answer.
Excellent, right? I'm looking for, if I notice the cosine of 30 degrees is radical 3 over 2, the sine of 30 degrees is 1/2. Let's give Kyle one clap on the count of 3, 2, 1. A couple people asked me, Mr. Paulsen, I don't know what the 1 over square root of 2 is. Everyone put that in your calculators right now. 1 divided by the square root of 2. Does that look familiar to some people? Yes. It's the unradicalized form of rad 2 over 2. This is why I say this, and it's extremely important. Right? On a PARC question, on an SAT question, on an ACT question, you might be looking for rad 2 over 2. But what I encourage you to do is use appropriate tools strategically and think about what are other forms of the radical that I already know. Okay? Let's all flip to page 3.
whoa.
Another one of the math practice standards is look for and express regularity in repeated reasoning. We have never done this, but we have been doing domain and range and transformations of functions the entire year. In fact, that is what we're going to be doing tomorrow. You'll notice I gave you a sine and a cosine curve, okay? I want you to really think critically and see if you can find the domain and range, the symmetry, the period, and the amplitude. All things we talked about over the course of the last 2 days. Okay? I want to see if we can do this. I'm going to give you 4 minutes at a level 1. I encourage you to take out 20.1 as a reference. Okay? I see Maria up there. She's an all-star. I see Melissa's already got there. Feel free to share what you did for her. 4 minutes, level 1, go!